we have just done area under a curve, okay, where the curve was y equals to fx. And we have seen that if A is a point, starting point, and we go till x, and if we denote the shaded area as A of x, then A of x was capital FP minus capital F of A, okay? F of x minus F of A, because the final point is x and the initial point is A, where F dash x is nothing but F of x. This is what we have seen till now. Now, we have also seen this thing, integration fx dx, and this is the indefinite integral. And this is capital F of x plus c, where c is a constant. Now we discuss the concept of a definite integral. Okay. So now let us see what does a to x fx dx represent. Now, what is a definite integral? Where we have a lower limit and an upper limit. Now, if you look at this graph carefully, fx into dx is a product of two real numbers, okay? So, suppose you have a rectangular strip, okay? And a very thin rectangular strip whose width is dx, okay? And it is so thin that the height can be considered as, this point is, some point, some x coordinate comma fx. The height can be considered as fx. So the area of this rectangular strip is nothing but fx dx. So what is the area of this entire figure? The area of this entire figure is the sum of such a rectangular strip where dx is very, very small. Now, we can see that this is a continuous process. The rectangular strips are going to be very, very close to each other. So therefore, we use this symbol of integration. This is nothing but, if you see that, it is an elongated S, which is S for summation. So since we are dealing with continuity over here, there are no breaks. So we do not use the summation sign. We use this sign. It means that my x is varying from A till this point. Okay, I'm moving like this. I'm taking these rectangular strips and adding these areas. So when I add these areas, I will get this definite integral. And therefore, this is nothing but A of x, which is f of x minus f of a. So this is the definition of a definite integral. So indefinite integrals are taught to learn how to calculate the antiderivatives, okay? For example, whenever I say f of x dx, so we basically need to find out an fx such that f dash x is equal to f of x. And we get this. But geometrically, the meaning is obtained when we put limits over here. So when we put limits over here, we actually get ax, which is a area under y equals to fx from a to x. And obviously we are considering that y equals to fx is greater than or equal to 0. For negative, separate cases are discussed where we multiply the sign of the integral by a negative number, -1. So this definite integral is equal to f of x, which is capital X minus f of a. So generally, if you write a definite integral whose limits are from a to b, fx dx, this is actually going to be capital FP minus f of a. Okay. So now we have differentiation rule. You can see that a to x f of x dx is equal to capital Fx minus capital F of a. So if you differentiate this, okay, you are going to get f dash x minus 0 because f of a is a constant. So that is going to be f dash x. So this is a very important result. This is fundamental theorem of calculus part 2. The first fundamental theorem of calculus is this. Okay. Also, if you change these limits, you can see that the lower limit is a constant over here. Okay. So suppose you have these limits as, a function of x over here and a function of x over here, f of x dx. So this is nothing but d by dx of, capital F of bx minus capital F of ax. What we are doing by definite integration, we are just replacing these limits. So the upper limit is bx and the lower limit is ax. And obviously we know that, capital F dash x is f of x. Okay. So, all right. So you can see that this is going to be d by dx of f of bx minus d by dx of f of ax. And now we will apply chain rule. So we will do f dash bx, then b dash x minus f dash ax, a dash x. So these are very useful results which can directly help us in obtaining answers to questions whenever we have these kind of things involved, differentiation involved. Okay. Now, suppose we need to find out a to b f of x dx. Okay. So how do we make a graph? This is a, this is b, and we want to find out this area. And now suppose I have a point C over here. Okay. So what you can do, you can write this area A1x and A2x. Okay. So you can see that A1x is A to C, okay, fx dx, which should be capital FC minus capital F of A. And A to x would be C to B fx dx, which should be F of B minus capital F of C. So if we add A1x and A2x, we will get this FC and this FC will get cancelled. So we will get FB minus F of A, which is nothing but the total area, AX. So this is actually equal to A to C Fx dx plus C to B Fx dx. So this is known as integration property over adjacent intervals. That means if we have two intervals, okay, and if we add these two integrals, we will get the integral over the interval AB. And this can be done for as many partitions as possible or as many as you want or as required by the question. For example, we have A, A1, A2, A3 till B. So we can break the integral accordingly. Okay. So from A1, A to A1, from A1 to A2, from A2 to A3, from A3 to B, and so on. Okay. Now, if you look at this integral A to B, k times f of x dx. Okay. Now, suppose I want to write what is this. So this is equal to k times A to B f of x dx. This is constant multiple property of definite integrals. The constant can be taken out. So, for example, if, a to b f of x dx is, capital F, fb minus f of a. Okay. So you can see that k a to b f of x dx is nothing but kfb minus kfa. Okay. So which is k times fb minus f of a. So if you have f dash, you know, capital F dash x to be f of x, okay, then if you take the derivative of this thing, this is nothing but k times this by property of differentiation. And therefore, by using this rule, this is equal to this. So hence this property holds. So these properties can be, expanded like this: a to b alpha fx plus beta gx dx. This is equal to alpha times a to b fx dx plus beta times a to b gx dx. So, of course, alpha, beta are constants. They cannot be variables, okay? Here, the variable under consideration is x, okay? So, anything that is involving x is not a constant. Alpha and beta have to be numbers or something not involving x. So this is about definite and indefinite integrals.